Hey everybody, this is Dr. Flight. I hope you're doing great today. This is going to be a video which you can stop, start, advance through to whatever degree you wish. It's simply a walkthrough of our homework assignment number 9 to give a little support and just kind of walk through the assignment, excuse me, and how you may approach it. This may be a challenging assignment depending on your flexibility with Excel and managing data. What I have for the homework assignment is the Word document that lists the assignment, the questions. There's 5 or 6 questions that just and this is kind of an analysis portion where as a researcher you sort of ask questions and then you look in the data to answer those questions, and those questions should align with or correspond with, if you will, the what the client's looking for. So if they're have a specific business problem, your research questions should help shed light on those on that problem, and then the data should be analyzed in a way that helps answer those questions. So there's just a variety of questions here, and again, this is an active learning assignment for you to kind of dig into. We also have the data set, which again is provided in the assignment. So this is a cleaned up data set also. And again, with this particular video, feel free to jump through it. Just go to the parts that interest you or where you need it. And I'll just kind of walk through some of this. So this cleaned up data set that I have here is a 608 or so respondents. It has been summarized a little bit. So just so you know, these 2 columns here are those first 2 questions um, summed up and then averaged. So we asked people to check the box if they own certain dupe brands. That was one question. There were 36 dupe brands. So if you see a number here, it says 0.388. That means this respondent, whose ID number is 3, this respondent checked 38.8% of those dupe brands. It's basically what that means. So, they had 36 brands to choose from. They checked 38.8% of those. And so that's the usage, then how much they use or access those types of brands. And then if we clicked over here to the Mastige brands index here or summary, then the same thing goes here. There were 48 Mastige brands they could have checked, and this respondent checked 20.8% of those. So that's how you interpret these first 2 columns. And in essence, what we did was we took the 36 dupe brands and the 48 Mastige brands, and we consolidated them into a summary variable so that we don't have lots and lots of columns of data for each of those brands. Instead, we just have one column for the dupes, one column for the Mastige. So this is a data reduction technique, and it summarizes each respondent's participation, if you will, or usage in those 2 product categories. Okay, so that's what those are. These other variables, these are all the scale variables that we have. Remember, we have 8 subdimensions that we're measuring. Each subdimension is classified here. What may help you too, and you should probably think about doing this, is you can pull up the actual survey, and if you do that, it's a Word document. It was provided earlier in the course. It's also located in homework number 8 if you want to pull that up. You can pull that up so you can see what the respondents actually answered and how that corresponds with the data set itself. Remember, there's this code book concept where you look at the survey and you look at the Excel file, and you should be able to correspond between the two. and make sense of both, quite frankly, as you're looking through that. So after we get through the first question, which has all those brands, then we have these sets of Likert like questions here. So this is that first set. And if you look at these questions, they deal with functionality and symbolism, and if that motivates them to buy products. So that's the FS subdimension for the scale. Remember, there are eight of these groupings, and they're denoted in the file in the data file, with these labelings. So this is the first set. This is the second set subdimension, the set of 5 questions. The third, these should actually all be AM, not MA, but these are all the same. In that you can change this if you want, just for consistency. You can make sure all those look the same. But we know that those are the next 5 questions, and so on. Okay, so that's the survey. Then we get into this area here is the treatment area. Respondents either saw the ad for a fictitious brand called Burst, or they saw an ad for CeraVe, and they responded to that ad with a purchase intention. And we also measure sun care familiarity, so familiarity with the product category, and then frequency of use in the product category. How often do you use sunscreen products? We have a couple test variables to confirm that the treatment was effective in familiarity. So people should not be familiar with the Burst. So this average of this column here should be very low. Familiarity with CeraVe should be very much higher, and it is. So that is a manipulation check. It's a check to make sure that the treatment of the ads does what we want it to do. There's a heat map question, which we may get into when we start doing some other analyses. And then we have a scale to measure purchase intention, whether people are likely to purchase this product or not. Okay, so let's walk through some of this. There's a validation check, which you've already looked at, and then we have some other things. So we get into the demographics back here, in terms of the demographic pieces, their ages, and so forth. And we also have a social media usage scale, if you will. We just have social media platforms, and we ask how often you use these. So that's another scale, or a set of questions that you could make into one data point. Okay, so anyways, let's jump into this homework assignment. Let's just walk through a few of these, just to give you a flavor for how you might address some of these issues. Okay, so first question, general descriptives. What's the average age of the sample? What portion of the sample makes between a certain amount of money? Frequency of education level, frequency. So we have frequency questions here, we have an average question here, and then we have, in an ordinal data point, a range of income levels. Okay, so for questions like this, these are highly descriptive. First question is average age. So on something like this, what we can do is, we remember this is your data set, so we can sort of add data, or look at different things. We're going to look at this column in particular. A couple things we can do. We can manually just kind of come down here, and we can type equal average, and then we can capture this array. So we can capture this array here, and what that's going to look like, if you look at this average, just gives us the mean. We'll click on that. This is going to be the average age for the data set. Okay, so that's kind of pretty straightforward, looking at that type of thing. When we start looking at frequencies, so the next question asks you how many people make less than 40,000. What percentage of the survey makes less than 40,000 a year? What percentage makes between 40 and 80, and what makes more than 80? So this is going to be the income column, and that's where we're going to draw this from. So it's this column right here. Remember, if we see a 99, it means that they just preferred not to answer, and so we want to exclude. We don't want to really consider them in the data set when we ultimately evaluate this. So we'll have to exclude the 99s, and then we'll look at the percentage of the rest of the data. So it's kind of like just a missing data point. You could just have, if you see a 99 in here, it could just be a missing data point like that. If you wanted to do that, you could do that. It wouldn't hurt the data set. It wouldn't impair the data set, because the 99 means nothing. It means blank. It means a non-response, basically. Okay, but when we look at this, we're going to have to consider kind of how that works. The other thing that we're going to need to do is look at the actual survey to know where 40,000 and 80,000, where those breaks are. So I'm going to use the survey here, and I'm going to go into this question right here. This is our income question, and so these are the codes 1, 2, 3, 4. Those are the codes for people who make less than 40,000. And then people who make between 40 and 80 are 5, 6, 7, and 8. And then people who make 80,000 or more are 9, 10, 11, and 12. So what we'll want to do is we'll want to combine those and find the frequency of those three groupings while we ignore anything that's a 99. Okay, so just conceptualize the problem, kind of understand what you want to do. We're looking at the survey, so we kind of know what some of these codes mean as they relate to the actual survey. So we go back to the survey and we're like, okay, this is the income thing. You know, mechanically, you know, if you want to just grind it out, you could take all this data and we could sort the data by that particular column. This would be kind of a get your hands dirty way of doing this, but this is certainly an option. We can sort this all this data by the actual column, which is column BN, or if you want to use the label here, it's income. So by income, and we're going to go from smallest to largest. So if we do that, now we look at this column, and you know, you could now at this point you could say, okay, anybody under, 4 and under, they make 40,000 or less. So we actually have, if we looked at how many respondents are in that space, there are 83 people who checked 4 or less. Okay, and then we have the people who are between 5, 6, 7, 8, and 8, 5, 6, 7, and 8. Those are the between the middle group between 40 and 80,000. Then anybody who checks 9 or higher in the data set is going to be making more than $80,000. But then we have to exclude anybody who is a 99. Okay, so that's because, remember, the 99ers are people who chose not to answer, which is perfectly fine. Again, it's not a problem to do that. So that's like a mechanical way, and you can grind it out, and you can come up with the number of respondents in each of those 3 batches. We look at those batches as 1 through 4s. Oh well, that didn't do right, but you know what I mean. 1 through 4s, and then the other ones. Another thing that we can do is we know our range here is 1 through 12. So we can do 11, 12, and then 99. And then beside this, so we know that's our range. Those are the options people can choose. Another thing we can do is we can do the frequency, the frequency kind of an array or of a set of numbers. And so what we need to do is we need 2 things. We need the data array. and then we need what they call a bin array. So this is going to be the data array. Okay, so we have that in there. And then the second thing we need to make sure that that's a comma. The second thing that we need is the bin array. And then if we do that, we can click there, and we get our counts, if you will, for each of these three areas. Now we know that the 1 through 4 group, this is going to be the ones who make less than 40,000 a year. And so we can kind of just say, all right, that's one group. The next group between 40 and 80,000 a year, and then the last group would be the folks who are more than 80,000 a year, because that's really the question. So again, we're sort of grinding this out a little bit. We can do a sum of these groups. So 83, that's what we had earlier, make between 0 and 40,000. And then we have 98 who make in that middle group. And then we have 313, they report earning the full amount, or between 80 and more. Okay, so that's kind of our count. That's the frequency count. The question is, what percentage or what proportion of our sample is kind of in this range? And so what we can do then is we need to know what the total number is, equals, so we'll just sum up the total here. And so this number here is our total number of people, excluding the 99s, right? Because remember, we don't need the 99s in there. So people who responded to this question, who answered it, were 494. And then what we can do is simply take the kind of divide and to find the percentage, 494, of each one. So 83 divided by 494 is going to give us an amount here, and these are obviously decimals. If you don't want to, if you just want to do it quickly, or if you want correctness and completeness, then we need to make sure that these are percentages. Percentage. There you go. Okay, so these are the kind of what we want to get, right? This is, at the end of the day, we'll find a nice pretty color to give that, just so it stands out a little bit. So 16.8% of the sample makes 0 to 4 up to 40,000. 19.8% make between 40 and 80,000, and 63.3%, 0.4% make more than 80,000 a year. Okay, so that's that question. That's that answer. That's how we do that. So for the first question, just the average income or average age, 30.31 year. That's years, so make sure you label it. And then what percentage or what proportion of the respondents make certain amounts of money, then that would be that question there. Okay, so those are the first two ones here in this general descriptives area. Okay, now doing the same process of doing the frequency is what you're going to do for each of these. Now for the last, so educational level, gender, and ethnic background, you got to go again into the survey, find out what those labels are, what those codes are for each of those. So for the gender question, if it's a 1, it's a male. If it's a 2, it's a female. If it's a 3, it's non-binary or third gender. If it's 4, it's other. And if it's a 99, then they prefer not to say. So again, same type of thing that you can do there. Ethnicity, we have these codes Again, the codes are there. Remember, this is nominal data, so 1 is not better than 2 or better than 3. 3 is not better than 4, anything like that. It's just a marker, right? It's just a label at that point. 1, 2, 3, 4, 5, 6, and 7 is other, and then 99 is there. Educational background would be kind of a similar type of thing. You might consider this ordinal because of strength of, or degree, if you will. But again, it's just a frequency. How many respondents check these boxes? And there's not a 99 on this, so there's not a prefer not to answer. It would just be blank if they preferred not to answer, or that's probably what it looks like in the data set itself. Okay, so pretty straight. I'm going to say it's pretty straightforward, but at the same time, it's, you know, a few steps here or there. Again, if we did gender, we have what 4 plus 99, 1, 2, 3, 4 plus the 99. Let's just confirm that. We'll just do this one real quick. 1, 2, 3, 4 plus 99, just to give you one more example. So again, this is gender right here. And so what we'll do for gender, I'm just going to drop down here a little bit just because. So 1, 2, 3, 4, and this is male, this is female, this was non-binary, and this is other, just so that we can kind of get a feel for that. So then we're going to do equal frequency. Again, we'll do that. We're going to capture this array. This is our, again, this is our data array for that one, you know, what we want to analyze. And then we're going to do our bins. And what we actually need to do is we actually need to add a 99 in here. We need to add a 99 in there because that was something that was there. Remember, we did it for that there. And so this is the way it is. So we have 195 males, 399 females, 5 non-binary, 0 said other, and then we had 5 in that group prefer not to answer. If we did a percentage type of a thing, which we're not asked to do, but if we did, we would not include 99. We would just simply do, you know, of those who answered, we had 599 answer, and then if we did our numbers, 195 divided by 599, then we would get our percentage, right? And those are the percentages of respondents. So 2/3 of our respondents indicated female, roughly 1/3 indicated male, and then a very, very marginal small percentage indicated non-binary or third gender. Okay, so again, that's kind of how we handle those types of questions. That should be pretty basic, you know, kind of descriptive data. And you know, these don't really relate necessarily to our research question, but sometimes when we're summarizing data, we want to describe the sample, like who was your sample, what are the you know, the distinctions in your sample is something that researchers will typically do just as a process of what we're doing. Okay. All right, next question. On average, how many dupe brands do people own? And how many prestige brands do they own? Okay, well that was that very first 2 questions in the survey, and the ones that we summarized. So I'm going to go back to the very front of the survey in the data set, and we've got these 2 columns. So what, on average, how many dupe brands do people own? And how many prestige brands do they own? Okay, that's pretty straightforward. We're just going to do some averages. We're just going to average. Again, we're going to average this column. And this again is the grinding it out way to do this. We have two different figures down here. Again, if you want to make this a percentage, no worries. We got those right there. We got 22.9% of the sample indicate that they own dupe brands, or people own 22% of the dupe brands that were listed, as opposed to 11.9. So 22.9 and 11.9% of the Mastige brands were owned. Now, as a researcher, we also want to look at the data and ask if this makes sense or not, if this has what we call face validity. And the dupe brands are more accessible to people and they're at a lower price point. Mastige brands are harder to acquire, they're more expensive, and they're luxury. It's a luxury category. So we would expect people to own more of the dupes than, on average, than more of the Mastige, and they basically double that amount almost, right? So that makes sense. That's exactly what we would expect to see. So the question here, though, is it goes a little deeper. So we answered this first part of the question. Are men more likely to buy dupes and Mastige brands as opposed to women, or men or women? Which of the two are more likely to buy these things? So for this particular question, again, this is kind of like an ANOVA, or it's really just a mean comparison, and it would really be kind of an ANOVA thing that we would do, which again in Excel, you need to do kind of a couple different columns, I guess. You have to set the data up a little bit differently when you do the data analysis for something like this. You can go into data, do data analysis. But honestly, one of the easier ways to do this is to just simply split the data on the file and then just run two means. So we're going to go up here. We know that gender is this column here, this BO. So what we'll do is we'll sort the data by men and by gender, and then we'll just do two means of the data that's there. And this would be the easiest way to do this. So let's sort the data. And again, oops, it was column BO. So we'll sort the data like that. Whenever you do this, just confirm that your column that you sorted is correct. And we actually know now that if it's a 1, it's a male, and the males stop. The last male is number 196. So 2 to 196 is the males, and then it goes down further. So what we can do here is we can do male, and we can do female, female, and we can do equals average. And we know this is going to be column C2, and we're going to go to C196. I think that, whoops, C196. I think that's what we had. And that should look about right. Okay, so if we did this accurately, that would be, again, we're taking the average of this column from C2 to C196 to 196 right there. 196 is right here, and it's where the males end. Actually, it goes to 196 there. It's where the males end, who are 1, and the 2s begin, who are females. Okay, so that's what we wanted to see. Now, this is interesting, obviously, because if our total average is 22%, then what we're looking at here is 8%. And again, I'm just going to convert this to a percentage so it's easier to see. So what we want to do now is we want to look at the female. We want to get the female only average. Okay, and we know that the females go from one, in this case it goes from after this 197 all the way 197 all the way to 590 594. Oops, 595, excuse me. 595, this column here, right, to twos. Because this BO is the gender column, the twos are the females. And honestly, I mean, we could calculate the average for the non-binaries, but we only have 5. I mean, so the average isn't going to be very reliable. It's just a really, really small sample. And it's not that we don't want to know what their average is, but it's so small that it would be non-conclusive. The sample's too small. We just don't have enough in our sample set to really draw any strong conclusions. So that's the only reason why we it doesn't really make sense statistically to capture that information. So, but 595 is where we're going to go to, and so what we're going to do is we're just going to do another average. This one's going to be 197 to 595, right? And that's what we want to go to, and we can again confirm that that's where the data range is. We have that selected, and so wow, look at that, 8.36 to so 8.36%, 30.24%. And if you'll notice that this is just what I'm dropping into this area here. So on percentage basis, are men more or less likely to buy dupes? No, women are far more likely to own dupes than men are by a large margin. That would obviously be statistically significant. That's a huge difference that men and women are vary on this. So let's also look at the mastige, and let's see if the same types of relationships exist. And wow, look at that, 386. So again, I'm going to drop 3.86%. I'm just filling in my form here, and 16.06%. Okay, and again, we just kind of have this filled in here. Okay, so that's a big deal. It's a big number. So, and we can put 22.91% up here for dupes, and we have 11.9% for mastige. And I'm going to bold it just to make it a little easier to see. No reason we can't do that. Okay, so wow, I mean, so again, kind of tells us something. Now, if I'm going to play devil's advocate, one thing I might say is, well, the brands that we listed are more gender specific for women than they are for men. So if you're talking like skincare products, cosmetics, and fragrances, they're probably going to skew a lot more heavily in ownership towards women. So that could explain this big difference. So we want to kind of go back and kind of help explain why this is the way it is. Also, it could just be more women own a variety of brands than men. Maybe more women are more remembering, like they may recall better the brands they own than men do. If if somebody just simply doesn't recall if they own a brand, or maybe they use a facial lotion and they don't know what brand it is, they might not check the box, and maybe men just don't remember as well. That could be an explanation too. So there could be lots of reasons why this is, kind of the way it is. And it could be just a genuine gender effect. Maybe women own more brands than men, and that could be just a function of things as well, right? So that could be something that we look at. Okay, so the next question though is, and kind of relating to the same category, or the same variables here. What is the correlation between dupes and mastige brand usage and age? So we've got three variables: one dupe, one mastige usage. So that's the second one, and then we have age. So we have a couple, three variables, and we want to know two different correlations, right? And the question is, do people own more dupes, when they're younger or older, or mastige when they're younger or older? That's kind of the question. So dupe use, dupe ownership actually, and mastige ownership, and this is going to be by age, and this is a correlation. I'm going to pull this down just a little bit so it's correlation. Now, when we do correlations, you have to have scale variables, and so just remember that integral or ratio scales need to be used. You can't do nominal and ordinal scale types when we do correlations. Typically, there is a bivariate correlation. There is a process where you could do an ordinal scale, and sometimes we do. But generally, you want these to be scaled variables, and all you need to really do here is just say the word correlation and spell it correctly. And Corel, sorry. Corel, that's the term. And now you're going to be asked for two arrays. So again, we're going to do our two arrays. Now, the first array we'll do is dupe, owned, and then the second array, again, will be age, because that's the two things we're kind of looking at here. So we have our dupe scores based on how many people use the dupe, or use these dupes. And then the second one, way over here, we're going to grab age. Now, I hadn't talked about age that much. In the data set, people inserted their birth date, and then what you can do from somebody's birth date is just simply take the difference between today's date and their birth date to calculate their age. And so that's kind of what we did here. We ran that, and we've got this correlation here now, and so we're going to do this, and ooh, look at this. Okay, so this is correlation. It's not a percentage. It's negative 0.148, and you can round that. 149 is probably what we'll do. Okay, so, and it's negative, so it's negative 0.149, right? 149. That's it. And again, that's going to go into this box right in there. So what does that mean? Okay, so a correlation of 0.149 is not super strong. We have a big data set here. We have a lot of respondents, so that'll be significant statistically. 149, again, it's not really strong. It's not a real strong correlation, but it is correlated, and it's negative. So you need to know the direction. So that means the older people get, the fewer dupe brands they own. Okay, so that's a negative correlation. So as age goes up, dupe ownership goes down, and the reverse, you could say. The younger people are, the more the dupe age, the dupe ownership goes up, right? So because they're inversely related. Okay, so that's just interesting to know. And again, remember, dupes are products that are a little less expensive, right? So now, what about prestige brands? So we're going to do basically the same calculation. We're going to only now, instead of dupes, we're going to move our first array over to make sure it's in the prestige space. And then we also want to make sure that our array for age is properly met there, right? And so we have, again, our dupe column and our age column. And we're going to find that this is also negatively correlated, although at a much, much less impact. So like half as much. And my guess is if you did some analysis, this is probably going to be probably not significant. It's hard to tell again with this data set, but it's pretty small. I mean, 149 is pretty small, and take half of this, and so the strength of the relationship is essentially cut in half when we look at prestige owned. Still negative, so that's interesting, but probably non-significant, and certainly a lot, half as strong as the relationship of dupe ownership and age. Okay, so I don't know that we can draw a lot of conclusions from that, except that the ownership and age are somewhat related for dupes, probably not related at all for prestige ownership. Okay, now I would have expected that to be positive and a little stronger, so that's a bit of an unusual conclusion or finding, right? As far as that goes. All right, so we're kind of moving along. You kind of get a feel for how this is going to work out. Next question, and again, I kind of want to just walk through some of these. I'm not going to do all of them, because then there wouldn't be anything left for you to do. But at any rate, we'll walk through maybe a few more of these. We have 3, 4, and 5. Number 3 here, create a composite score for purchase intention, and then calculate the mean purchase intention for duper brands and the Burst brand and the CeraVe brand. Do the averages make sense? And then why or why not? And then we have some, again, the same same activity up at here, only now for purchase intention by brand. Okay, so there'll be a little bit more splitting up the data that's going to have to happen. So this is called a 2x2 because we have the treatment, which is a two thing, Burst and CeraVe, and then we have a gender, men and women, which is a 2 thing. So it's a 2x2, box, if you will. We do this quite a bit actually in marketing. We have 2x2 boxes all the time when we're comparing groups and some things like that. Okay, so a few more things involved here, but these boxes, again, you're going to have to do a 2x2. You're going to have to sort twice. And again, I'm showing you kind of the mechanical way to do this. So we can do it through some other methods too, but this is just kind of the grinded out way. So creating a composite score, and then comparing dupe and CeraVe and Burst on these averages of purchase intention. Okay, so let's do a composite score. You'll have to do some of these later, so let's do one so you know how to do them. So when we do a composite score, what we're doing is going to take an average of a group of items. Okay, so we get to purchase intention. It's a 3-item scale. We're going to do a composite score. So what we're going to do is we're going to create a column. So this is going to be a PI, and I call it usually average, but you can call it composite if you wanted to. You could do something like that, and we'll just make that. We'll just do that. So we could do that, and all we're going to do is we're going to do an average of our PIs. Does that make sense? Just do an average of a PI, and we're going to get a score. It's like a global score or a summation score of these three variables. This is also a data reduction technique. So we're taking three columns and we're turning it into one through a summary statistic. And so this is a powerful way to do this. Again, we're just going to create this for this entire column. Now again, this average should certainly be between 1 and 5. And we have ones here, we have fives, we have numbers in between. So that kind of makes sense as well. Okay, now, and again, the question is, what is the average purchase intention for dupes? What's the average purchase intention for mastige? So this time, instead of ordering the data by gender, we're going to order it by treatment. So we're going to capture the data, and again, this is just a little bit of a mechanical thing that we're going to do. The very last column here is treatment, BR. So let's sort the data by column, and we got it all there. So by treatment. And so again, visually inspect to make sure that worked. The respondents were randomly assigned burst, which is number 1, and CeraV, which is number 2. So roughly half the data will be one or the other. And so we go to 304 for our bursts, and then from 305 all the way down to the rest of the data, we have the rest. So we have our burst, and we have CeraV, and we're going to do an average score. This is column BC, and we're going to go from 2 to BC 30, is it 305? I think it might be. And it's going to be a 2.62. Okay, and again, this is not a percentage. This is on a 1 to 5 scale. Right, so that's 2.6, 2.62. The likelihood people are going to buy burst, or purchase intention to buy burst. And again, we can sort of just make sure that we've got our column captured correctly. So I actually need to go to 304, it looks like, not 305, which is fine. We'll adapt this to 304. Next one, we're going to do the same thing, only we're going to go from 305, so again this is CeraV, down to 609, and we're going to see what shakes out. All right, so very cool. So we have these purchase intention scores. They're, again, the composite score that you created. The average burst composite score is 2.6. Okay, so 2.62 for burst and 3.16 if we round up for CeraV. That's kind of our answer. That's what we got, right? And now, big question here, do the averages make sense? Why or why not? Well, burst is a dupe. It's less fancy. It's relatively unknown. People don't know the brand. There's not a brand equity, brand knowledge associated with it. CeraV is more well known, it's better quality, it's better established. You'd probably expect people to buy that well-known brand more readily than the other. Now, one of the caveats that you need to really think about as a brand manager, the burst product was like $6, $7, $8. The CeraVe product was something like 28, 29, $30. There's a huge price difference, and the products themselves are described identically. Like they do the same thing. It's the same product functionally. One is at a very low price with no brand name equity. The other is a very high price with a high brand equity. So just kind of, again, we often say price drives everything. Like price and purchase intention are inversely related. If the price goes up, purchase intention is going to go down. But this clearly isn't the case. When you have a strong brand, when compared to an average brand, it doesn't happen. And this is like one of these effects of brand equity. You build a lot of brand equity, you are able to do what we're able to charge what we call a price premium. And in this case, that it doesn't hurt anything that we're really doing. So again, a very powerful kind of conclusion and result here, and it has really big effects if you're a brand manager. This is kind of, I think, what we would expect. So do these averages make sense? They probably do, but they may not either, just depending on how you view that. Okay, so very good. We'll move on to the next item. So now we're looking to extend this. Are men or women more likely to buy dupes and masstige brand? What's the correlation between dupe and masstige? Oh, well, this is a bad question. I need to rewrite this. I'm so sorry. This should be purchase intention. Huh. And age. I should have double checked that. I meant PI. Yeah, there should be PI in here. Okay, so this is going to be a little bit different because again, it's a 2x2. In the other one, it wasn't so much a 2x2 because these are separate variables. Dupes owned and masstige owned are separate variables. Here, PI is the same variable. It's one variable split twice, or split, yeah, twice. So what we need to do, this is going to be a little bit of a tricky thing because there's going to be 4 boxes, so there are going to be 4 means that we look at. We're going to take the data and we're going to sort it, and we've sorted it by treatment already, and now we're going to sort it by gender. So there's going to be 2 sorts that happen, and there are going to be a total of 4 things we're going to look for as we do this. Okay, so as we kind of look at this, we look at this. We look at this column here. So this is the column that has the treatment in it. And then we're going to look at this column here, and this has the gender in it. Okay. So what we'll do is we'll do this like some type of a chart. We know these are PIs. We're going to have burst, and we're going to have CeraVe, and then we're going to have male, and we're going to have female. Right? And let's just confirm that that's exactly what we're looking for here. So we have men and women, we have burst, and we have CeraVe. So we've got these 4 categories, and these are all going to be purchase intention. So it'll all be the same column here. So now what we need to do though is we go up to the top and we look at the very first set of data. So we look at these guys here and these guys here. So we know ones are bursts and ones are males. So we got to kind of go down here and we've got to see where this stops. Okay, so at some point here we've got, let me just yeah, we're going to move this over. Sorry about that. We got this stops here. So we've got the burst continuing, but now we move into females at 102. So at 101 we have males and their bursts. Okay, so we come down to the bottom, males bursts, it's going to get the average. And this is going to be column BC 2 to BC, what did I say, 104 or something like that, 102. Let's take a look and see what that is. I might not have gotten it quite right, so we can get it right. 101. It should be 101. Okay, but then at 102 we have females burst. All right, females burst at 102, and they go down to 102. They go down to here. They go down to 300 literally. They go right down to 300. So they go from 102 to 300. The females do. Okay, so this actually goes to 101. These guys here go from 10. Oh, no, sorry. These go from BC 102 to BC 300. Right, so this is female and this is male. So again, so we're taking the bursts so the one in the treatment column and the one in the gender column, averaging those to be the male, one in the treatment column, two in the gender column to be the female. Right? That's how we get those averages. And you notice that women are slightly more likely, as it turns out, to buy the product than males. So we have 2.68 to 2.5. Will that be significant? Probably, again, because of our sample size. It may be, it might be, because we have a fairly good sample size. Now we're splitting the data 4 ways, so the samples aren't as big when we do these cross category comparisons, but they're getting there. All right, so 2.5, 2.68, and now let's look at CeraV. So remember, CeraV again is the 2 in this BR column. So once we start getting into these 2s, we got CeraV. Once we have the ones in this BP column, those are males. So we have 305. That's where we start. 305 down to 399. So 305 to 399. This is going to be 305 to 399 in this. Again, that's going to be this column up here. You can kind of see where this begins. So it's this column of data there. And again, it's CeraV, so we're going to expect a higher number. And then we're going to do the females. It will be starting right here after 399, because we have the females starting here at BP where the 2 is. CeraV is 2. So we go from 400. And I'm just scanning here, 400 to 599. That will be the range for this one here. So 400 all the way to 599. Okay, 3.2. And actually, when we look at like these differences here, the difference between these two are about 14 hundredths, I guess, because we get 307 to 320. The difference between these two are about 18 hundredths. So the differences are about the same, kind of nominally, if you will. Percentage wise, it's smaller. Like so, this percentage change between male and female is larger because the numbers are smaller than this, but nominally they're about the same. And maybe that's significant. That may be big enough to be a significant change. I don't know. We have a 2.50 or 2.05, yeah, 50. I'm just going to update this on our chart. 3.07, 2.69. And again, we're going to round here, and it'll look a little bit like this, right? So those would be the numbers that would go in there. Okay, this last piece here, we did a correlation before, so you can do this correlation again. You don't need me to do this. It's just the correlation between age and then the composite variable you created for PI. It should be PI in here. Okie dokie. So that's that question. Now moving on, I've kind of walked through this, and again, it's just kind of, you have to muddle through this. There are in Excel, if you want to use the data analysis packs, you can absolutely do that if you have access to that with your software. So these correlations, we can do those there. Honestly, just because I'm familiar with just typing in the formula, it's easy to do that as well. You will need to do a regression later on, so we have to do a regression, so you'll need to do that.